let's now continue our discussion under geometric design for highways. Now this time we will consider the vertical curve sag curve. Now as we described in the earlier video, for the sag curve, the vehicle will first travel a negative grade of the highway, then eventually goes on a positive grade. So it goes downward and then upward. Now there are three criterions that we will consider in solving for the length of the sag curve, and the first one is the headlight criterion, next the comfort criterion, and then the appearance criterion. Now stopping sight distance and sag vertical curve design. Sag vertical curve design differs from crest vertical curve design in the sense that sight distance is governed by nighttime conditions, because in daylight, sight distance on a sag vertical curve is unrestricted. Thus, the critical concern for sag vertical curve design is the length of roadway illuminated by the vehicle headlights, which is a function of the height of the headlight above the roadway and the inclined angle of the headlight beam relative to the horizontal plane of the car. So this is the height of the headlight above the roadway, and here is the inclined angle of the headlight beam relative to the horizontal plane of the car. So we got there the angle beta. Now as for the PW's requirements, the headlight height is 0.60 meter, and a 1 degree upward divergence of the light beam is used in computing the length of the sag vertical curves. Now we have here two conditions. When the length of the sag curve is lesser, or when the sight distance is lesser than the length of sag curve, then we will be using this formula. Now when the sight distance is greater than the length of the sag curve, then we will be using this formula. Now L is the length of the sag curve, S is the distance between the vertical and point where the 1 degree upward single of the light beam intersects the surface of the roadway or stopping sight distance. So this is the S here in the figure. So it goes from this portion of the the vehicle up to the tip of the light beam as it intersects the roadway. Now as for the length of the curve, we have here the L, as you can observe, from this point towards this point. Now E is the algebraic difference in grades in percent. Okay? Now for the comfort criterion, we have their length of the sag curve, the algebraic difference in grades in percent, the maximum velocity of the vehicle passing through the sag curve in kph, or also the design speed, and this is the appearance criterion. We will check which among these conditions will be applicable in the problem. Now it says here, for the overall safety on highways, a sag vertical curve should be long enough so that the light beam distance is nearly the same as the stopping sight distance. Okay, let's solve for example number 1. So for example number 1, it says there, determine the minimum length of a sag vertical curve between a negative 0.7% grade and a positive 0.5% grade for a road with 110 km per hour design speed. The vertical curve must provide 220 meters headlight sight distance. Now here we are to determine the minimum length of the sag vertical curve. We're looking for L. Now from the formula, let's try first the first criteria for the headlight sight distance. Let's assume that here S is lesser than L. Okay. So, but first let's put the given. So we have there G1. The G1 is negative 0.7%. G2 is positive 0.5%. Then the design speed is 110 kilometers per hour. Then the sight distance is equal to 220 meters. Now assume that S is less than L. So we will be using the formula L is equal to AS squared over 120 plus 3.5 S. Okay, but first let's solve for the value of A. For A, that is equal to G2 minus G1 in percent. So we have there G2 is 0.5% minus negative 0.7%. Therefore, difference in grade now is 1.2%. Then let's substitute the value here. So this is 1.2. S is 220 squared all over 120 plus 3.5 times 220. So the value of L now is equal to, so that is 65.26 meters, and this is less than S, which is S is 220 meters, so not okay, or we should just say assumption is wrong. Well, let's try S is greater than L. Then the formula for this is equal to 2S minus 120 plus 3.5S all over A. Now we have there the value for S is 220 minus 120 plus 3.5 times 220 divided by 1.2. So L now is equal to negative 301.67. So it's a negative value. So, well, we will not use that. How about we check for the comfort criterion. For the comfort criterion, so we have there AV squared. So we have there AV squared over 395. So L is equal to AV squared over 395. So the value of A is 1.2. V, the design speed is 110 squared, and that is divided by 395. So L now is equal to 36.76 meters. Then let's try to check for the appearance criterion. For the appearance criterion, so this portion here, so we will check if one of them is applicable for this problem. So for instance, letter A. So for letter A, it says there V is greater than 60. Anyway, what is our V? Our V is 110 kph. So okay, so for criterion, appearance criterion letter A, we have there 110 kph is greater than 60. Okay, that is correct. Next, it says here A is less than 2%. So our A here is 1.2. So 1.2% is less than 2%. Okay, that is okay. So it fits for A. Therefore, L is equal to 60 meters. But then, let's still continue if it fits the others. So for letter B, it says there for B, when V is less than 60 kilometers per hour, well, our design speed is 110, so we will not be using B. C, for letter C, when A is less than 2%, okay, so our A is 1.2%, it's less than 2%, okay, it satisfies the criteria, so L is, therefore L is equal to 60 meters. Now for D, it says there when V is greater than 60, which is correct, 110 kilometers per hour is greater than 60 kph, and it says there A is greater than 2%, which is wrong. Our A is 1.2, so it is not applicable. So among these values of L, of course we will not be using negative value negative 301.67. Among these two, who will be used? So therefore, we will use L is equal to 60 meters. Why? Because it is lesser than and nearer to S, 220 meter. Okay, so that is for example number 1. Next, for example number 2, compute the minimum length of vertical sag curve that will provide 130 meters stopping sight distance for a design speed of 80 kilometers per hour at the intersection of negative 2.3% and a positive 4.8% grade. So we will put first the given. So given S is equal to 130 meters, design speed of 80 kilometers per hour, our first grade here of negative 2.3%, our second grade of positive 4.8%. So therefore, we have a value for A, for G2 minus G1 in percent, we have there 4.8 minus negative 2.3. So A now is equal to 7.1%. Okay, now let's assume a value of, for the first one, course, assume S is lesser than L. So again, from these formulas here, okay, we will first use the for this headlight sight distance, next for the comfort criterion, then the appearance criterion. Right, so assume S is less than L, and the formula for L for this condition is A S squared over 120 plus 3.5 S. Input the value, this is 7.1, then S is 130 squared divided by 120 plus 3.5 times 130. So L now here is equal to 208.68 meters, which is greater than S, and this is okay, meaning assumption is correct. Okay, because S is 130. Now let's check for the comfort criterion. For the comfort criterion, we have the L is equal to A B squared over 395. A is 7.1. V is 80 squared divided by 395. So L now here is equal to 115.04 meters. Now next, let's check for appearance criterion. Okay, for appearance criterion, again, let's check for A. It says there, A is, for A, design speed V is greater than 60. Now our design speed here is 80. So for A, we have there 80 kph greater than 60 kilometers per hour. The next one is, says there, but A is less than 2%. In the problem, our A here is 7.1. So it does not satisfy the condition. So we will not be using A. Let's go for B. B is when V or design speed is less than 60, but our design speed is 80, so we will not be using B. Let's go to C. C is when A is less than 2%, but our A is 7.1, so we will not be using C. Let's go to D. D is when design speed is greater than 60, so yes, it is. Our design speed is 80 and it is greater than 60. And A is greater than 2%, and that is correct because our A is 7.1% greater than 2%. So we will be using D. Therefore, we will use L is equal to twice of V. Therefore, use L is equal to twice of V. Twice of V is 80. So L is equal to 160 meters. So we have here three values for L. The first one is 208. We have here 208. We have the second one 115. Then the third one is 160. So which among these three will we use for the length of the vertical curve? Use L is equal to 115.08 meters, which is lesser than and nearer 2s is equal to 130 meters. So that is our sample problem number 2. So we're computing for the minimum. Okay, next for sample problem number 3. Compute the minimum length of vertical curve that will provide 190 meters stopping site distance for a design speed of 100 kilometers per hour at the intersection of negative 2.6% grade and a positive 2.4% grade. So the given is S is equal to 190 meters, the design speed of 100 kilometers per hour, the first grade which is negative 2.6%, and then the second grade which is positive 2.4%. Therefore, A is G2 minus G1 in percent. G2 is 2.4 minus negative 2.6. So A is equal to 5%. Okay. Again, let's assume. Okay, let's have this S is greater than L. And the formula for that condition is 2S. L is equal to S equal to 120 plus 3.5 S all over A. Okay. So substitute the value for S, which is 190 minus 120 plus 3.5 times 190 divided by 5. So L is now equal to 223 meters, which is greater than S is equal to 190 meters. So it is wrong assumption. Wrong assumption. Try S is less than L. So here we have L is equal to AS squared all over 120 plus 3.5 S. So this is 5 times the S of 190 squared all over 120 plus 3.5 times 190. So L is now equal to 229.94 meters, and this is greater than S of 190 meters. So okay, correct assumption. That is the value for L. Now let's check for the comfort criterion. So check for comfort criterion, which is L is equal to AV squared divided by 395. A is 5, design speed is 100 divided by 395. So L now is equal to 126.58 meters. Now next, let's check for the appearance criterion. For the appearance criterion, again, we will check them one by one. For letter A, it says here when V or the design speed is greater than 60. Now our design speed for this problem is 100. So okay, that is correct. 100 kph greater than 60 kph. Now for the A, Says there A is less than 2%, but our A in the problem is 5%, so we will not going to use A. B. When V is less than 60, so our V is 100, therefore we will not use B. C. When A is less than 2%, remember our A is 5% in the problem, so we will not be using C. For D, says there, design speed is greater than 60, that is correct. And A is greater than 2%, and that is correct. Our A is 5%, greater than 2%. Therefore, we will use L is equal to 2. Our design speed is 100. Therefore, L is equal to 200 meters. Now, among these three, L, which one will we use? So, use L is equal to 126.58 meters, which is lesser than and nearer to S is equal to 190 meters. So that is for our sample problem number 3. Okay, so that's all for the sag vertical curve.